Hello, everyone, and welcome to another on-demand Power BI session at the Microsoft Business Application Summit. My name is Lauren Faber, and I am a program manager on the Power BI Customer Advisory team. And today I am very excited for a unique session with a Fortune 500 pharmaceutical company that is headquartered in New Jersey. And we will be talking about how they have utilized Power BI and Visual BI's ValQ for innovative planning capabilities. Our presenter today is a supply chain management finance director at the company that he works for. So thank you so much for being here today to talk about the solution at your company. So the first question that I have for you is, what was the original state of data and BI within your company?
Sure, thank you. So the data state was a fragmented set of data sources that contained the information that were required to perform the economic modeling and evaluation and metrics that we needed to calculate. So we were going through multiple data sources, some Excel-based sources, some flat file-based sources, and then others around, our ERP system, which was SAP, and planning systems, which were rapid response and other cloud-based systems. The tools we used, you see on the right here, we had a fairly fragmented set of tools that we used that were basically driven by the development of the group that was doing the analysis. So depending on what area of the company did it, they may have picked the tool that they were most familiar with, or at that point in time was the popular tool of choice for that time frame.
So what was the new goal and vision that you had for BI at your company?
So what we needed to do, and it was really around the whole demand through delivery cycle. So starting with the demand forecast from customers, and then through the delivery of the product back to those customers, that whole wheel of activities, we were looking to do a kind of an end-to-end analysis, understanding the cost drivers, the costs, and a whole bunch of performance metrics throughout that collection or connection of processes. So we were looking to get a lot deeper than what we would typically do, is kind of the P&L analysis. Examine your cost of goods sold line, examine your revenue line, do some ratios. We were looking to get much deeper than that, down to the actionable areas of the business that were really driving the economics and therefore the finances that we were seeing in our financial results. So it was really a business focus where we were looking to bring together a lot of data, bring it together in a coherent manner that would allow us to perform this modeling, to understand implications of certain actions that we were contemplating taking. So the why and kind of the process we followed to implement this analysis that we were looking to perform, we started with working on the data. So we needed to establish a common data assumption or a common data layer that would provide alignment and coherence between the various data elements, as well as ensure some consistency and accuracy from all the many and sundry data sources that we were pulling information from. And what that allowed us to do is it allowed us that just the fact of bringing all the data together in one place eliminated a lot of redundant work. So applying this technology and getting a data platform that was consistent and common really eliminated a significant amount of work to produce analytics and analysis in support of the business. The other thing is it provided line of sight across what I would call silos, or just basically organizational structures within the business that may or may not look at things the same way. What providing this did is allow to see kind of through that and understand economic impacts of changes throughout the silos. In doing that, it naturally highlighted those areas where we could have some impact. So the areas where we saw significant spend that was being driven, that perhaps was the area of focus to start making cost improvements or efficiency improvements and the like. And the fifth bullet here is reducing the bias that's always inherent. Letting the data drive the decisions and drive the analysis, you do eliminate a lot of the what I would call management by analogy. And that is, you have a story that may or may not be current that kind of guides your thinking on something versus the data-based approach, which is like, here's the facts, here's what's happening, and then we can align around that and move forward. And last but not least is developing what-if capabilities and analysis quickly.
So how did Power BI fit into this overall vision, and what ultimately was the deciding factor in you ending up going with it for your visualization tool?
So one of the things, and it's the first bullet here, it's the data modeling because of the complexity. So that data modeling capabilities within Power BI to be able to bring that data together and develop the relationships and the flexibility to perform analytics on the fly and add new calculations quickly, and kind of the low code is where this comes into play. Being able to pivot quickly and develop new relationships and develop new metrics off of those was really quite helpful in our journey. The functionality is terrific. The visualizations are natural to use, especially for folks that are already familiar with Microsoft products. It is scalable, adding additional users and the security that goes along with it, providing that is really straightforward. The last but not least, like I said, we had a lot of different data sources, and the data source connection capabilities is all right out of the box.
And one of those first things that you mentioned was the data modeling. What does the back end of your solution look like?
So this is the platform we're POCing, which is to take all that data and move it to the Azure environment and then perform all the transformations there. Which is, and I break them into two stages. It's really stage one, make the data fit for purpose, and it's a matter of organizing and cleaning and purging, getting rid of the stuff that's the old data that doesn't have any relevance anymore. Why clutter up a user with having to navigate through that? Get it out. Organizing and establishing the relationships, applying the appropriate business logic to make it clear to the end user what it is they're looking at. The second stage is kind of now building on top of that and leveraging that data platform by automation, looking for insights and analytics, looking for detecting anomalies, looking at modeling changes, and last but not least, predicting, using the data as the basis for predictive analytics and understanding what may be happen or where we're trending going forward. So all of that data manipulation and transformation is in my mind the key to the entire application development process. And you see that our data serving and interaction layer is really around the Power Platform, whereby we use Power BI to present the data. We use Power Apps to manipulate anything. So any time a user would need to interact with the data, it would be done through Power Apps, which is embedded into Power BI. And then, of course, there's always circumstances where you need to pull the data into Excel to perform some kind of one-off analysis or just get your hands on the data. But the idea is it's the same data that your Power BI analytics were based on. So when someone pulls the data into Excel, they're using the same data foundation that was used for the Power BI dashboards and visualizations. And what you'll see, what I'll demo a little bit later, is the kind of the Power BI side of it. But this is what's under the hood, so to speak.
Can you tell me more about finance data analytics in general and what the process of integrated planning looks like?
Sure. So this is a picture of our integrated planning process. Everything starts with a demand signal. So that's what you see at the top, kind of in that blue box, is the flow of the units starting with demand. Everything starts there. So the demand then feeds your supply network plan, which is how are you going to produce the materials to meet your demand. The next step down is the financial supply chain. Is as a global company, things are moved around the world to plant sites around the world, so they need to go through the appropriate channels to get there. So there's companies that may not necessarily do any of the work or perform any of the manufacturing, that in order to import or export into certain markets or locales, you need to go through. So that's kind of that piece of the puzzle. And then last but not least, once you produce your materials, you need to then manage the inventory, that inventory that you've built, as well as distribute them, get them to the customer. So that's kind of that vertical lane where the units are really the drivers of the financial outcomes. The financial outcomes are the horizontal swim lanes, where the various financial assumptions are applied to those volumes to arrive at what you see in the far right in red, which is the various forecasts and analysis that naturally occur through this cycle. So taking the first swim lane, your demand, well, what do you want to, what influences your demand and turns it into a financial? Well, it's applying a price to it. So it's applying a pricing assumption to the demand, you get your revenue forecast. That second swim lane now is based on, okay, this is production. Well, what do we need to produce? Well, we've got materials and supplies that we need to procure. We need to add headcount, which is labor. We have capital investments for the machinery on the shop floor and whatnot. We've got factory overhead. Just what does it cost to run the factory? The electric bill needs to be paid. The property taxes need to be paid. You need to build a parking garage for the employees to park in. All those types of things are brought in through that. Again, since we would need to move product from site to site to perform the various stages of manufacturing, you need to move it. Well, how do you move it? You either move it via train, plane, or truck. So there's a freight cost to move that. If you're moving across the border, you may have to pay duties to import the product. So that's another aspect of running a supply network. The next to last one, production management, we actually spend a lot of time and we get a lot of utility out of the Power BI platform to understand production management. And that is the timing and scheduling of the events. You know, what is the lot size we want to package to? You know, how many do we want to package in a lot? What's the run time versus setup time or switchover time on our factory line, on our factory floor? It's understanding all that and how it influences really all the resources that are required and the time aspect of performing the manufacturing process. Because at the end of the day, time is money. That's very true. And how can we optimize the output over time and thereby become cost efficient at the same time? Last but not least, there's contract manufacturing. Those are cases where we don't have enough internal capacity and we need to reach out to external parties to perform some of the manufacturing processes. Well, obviously there's a cost associated with that and a cost analysis that's required to understand what does it mean to offload that manufacturing outside the company? What's the cost structure internally versus the cost that we would be charged by the external contract manufacturer? So it's kind of understanding all those factors which sometimes move together and sometimes work against each other to understand the financial aspect of the production process. So once the supply network financials are done, as I mentioned, moving things around the globe, moving product around the globe requires some transfer pricing to move it from one company to another affiliated company. So that becomes what you would call a tax forecast. So those same units that start with the demand become the production plan or the supply plan also inform what we're going to move from one company to another to get them from site A to site B to perform the manufacturing processes. And last but not least, there's all the costs associated with holding inventory. So it's the cost to insure it, to warehouse it, discards. So do we have an expiration where we need to destroy the product because it's no longer saleable? The sales order management process. What does it cost us to take and fill a sales order? Delivery, that's the last, I would call it the last mile delivery to get the product from the warehouse to the customer. The customers may be wholesalers, they may be hospitals, they may be any varied number of customer patterns can show up in different markets, but it's really getting the product to them. And last but not least, inventory projections. And that's a way of saying how much cash are we going to tie up in our inventory? What are the appropriate inventory levels? What are the appropriate safety stocks? And what's the financial impact of adjusting those safety stocks, or building inventory in some cases for certain reasons, or bleeding inventory in certain cases for other reasons, and understanding the financial impact and implications of all those potential decisions. So really what we're looking to do is take all of these factors and treat them as levers, and understand that if you pull a lever in one swim lane, what's the financial impact in another swim lane, and integrate all of this data together.
That was phenomenal. Thank you so much for that explanation. I would love to be able to actually see some kind of demonstration of how you're actually using these planning capabilities within Power BI. Could we go to a demo now?
So after we've established the demand signal and understand what we need to produce, now it comes down to the production requirements and understanding how we're going to produce that and the costs associated. So this next analysis really is an end-to-end understanding all the steps in the manufacturing process, where they occur, and what the cost structure is at each step in the process, which finally gets us to an accumulated cost for the material that we're going to be selling. So this is a decomposition tree, which is very helpful in understanding that, which allows us to navigate through a whole lot of data really quickly, and based on the bars, demonstrate the cost drivers, or the cost impact of each step in the process, each plant that touches it, as well as what are the cost components that that plant is adding to the production process. And understanding all of that on a per unit basis, which allows for kind of an end-to-end visibility over a many-step process that's apparent down in this supply chain visual, which goes through all the steps to make this particular product. And there's quite a few that just it's unwieldy to navigate at a detailed level. So the idea is decompose that cost into the components, find the ones that are really driving the cost, and then use that to filter down the list of steps and find where that cost is being accumulated and what steps it's being accumulated in, and then narrow your focus and look to that area for opportunities. So once we've established the end-to-end view of the costs and identified a particular node in the supply network that is of interest or that has some leverage to it, the next step is to go to what we call a step visual and look at the cost embedded in that step. And this allows us to look at the costs on the shop floor, understanding the labor and other components, understanding how much that translates to per machine hour, understanding how much that then translates to per unit, and understanding our throughput. How many units per hour are we able to produce at what cost? That also allows us to take a view of the overhead. So understanding kind of our shop floor allows us to apply the overhead, because for us, applying the overhead is based on the number of machine hours performed on the shop floor. So that's the overhead allocation basis that we use, and you will then get the overhead coming in a very similar fashion. So you see the rates, you see how much per unit, and you see how much in total we're going to spend to produce this particular material. Last but not least, in this example at least, there's the components or the materials that are purchased to produce the particular manufactured item. And it's how many do you need? What are they? What do they cost? And that's the next level of analysis that goes literally to the material itself that's required to perform. This is a bill of materials that is needed to perform that production process, and getting all the IDs of those materials and understanding how much of each we need. And this factors in any waste we would need. So once we've understood the end-to-end cost structure of manufacturing a particular material or a group of materials or family of materials, the next step of the analysis is to now look across the portfolio of materials that a particular site may be tasked with manufacturing. So it's understanding the trade-offs and contention and constraints of manufacturing multiple products. So it's kind of taking that end-to-end view at the product level, but then taking a cross-matrix view at the plant or manufacturing site level to understand what are the different contentions for the resources that that plant faces. What are the various products that need to go through that, and what is the overall cost of anything that that plant touches? All of that goes together to provide kind of a holistic view of the manufacturing process, not just one lane or one plant. So this all brings me to our simulation and visualization and reforecasting, I guess you could call it, capability that we've embedded into Power BI through the use of ValQ. So ValQ is a visual that provides modeling capability, simulation capability through a series of setups and assumptions that you can bake into the model. And what we're doing is we're baking a lot of economic assumptions into the model to arrive at what is the final cost per unit of a particular portfolio of products. So we start with a unit basis, but that can quickly expand out. And what you'll see is a lot of the things I discussed when going through that integrated planning slide are apparent as we look at this model, this simulation model. Starts with demand, filters down to supply, and then the spending to support the production processes is captured, which will end up resulting in our final cost. The nice thing about ValQ is that you can link all these relationships together. So for instance, if I change demand, it will immediately, and that depending on where I change demand geographically, if I change demand in Asia Pacific, it will automatically update the supply requirements in the network that supplies Asia Pacific. So that's as simple as taking a particular product in a particular region and changing it, applying an assumption to it. So I can increase it, I can decrease it, and again, I'm doing this over a number of years. So you can change it over the time frame. You can pick the time frame you want to change it just by sliding a slider, or you can manually enter your new figure and releasing it. What happens is once you release it, the model calculates all of the implications to demand, but if you look, it also has provided supply requirements. So in order to meet the demand that I just modeled, it's gone and updated all the supply, which is by stage and by plant. So it's automatically tied those two pieces or integrated those two pieces of data together. And it's actually put the supply to the group of plants in the network that would support that region's demand. Okay, so I don't need to perform this in Excel, which would be an absolute nightmare because of all the data that's involved. It would not be a simple task. So this allows you to quickly, as you saw, as just sliding a slider or changing a number, you quickly get supply requirements, which then in turn drives spending. So it went all the way down because once I change my demand, it informs my supply. So now I know I need to produce this much more on this set of resources in these sites. Well, once I do that, it also updates the machine hour requirements to make the additional supply, which then implicates how much do I need to spend to run the machines that much longer in this example. So the spending part actually gets down to the various cost buckets which I spend on. So if I take a particular example here, and this is one of the plants that does the packaging, I see all the components of the spending, including the machine hour requirements, and all the different components of spending. So I see my labor costs, I see my other costs, I see my depreciation, which would be my capital costs. And I'm able to manipulate any of these as well. So I can literally drill this entire model down to all the individual components or buckets of cost that associate to it and that drive it. And I can model changes there. I can model headcount changes. So the system is configured, or the simulation is configured to automatically drive off of supply the costs. So it will scale my headcount accordingly based on some fixed and variable assumptions. It will scale the headcount and say, you know what, to produce this much more, to run the machines this much longer, we would require this many more heads. So based on that, it will take a headcount projection and cost it, and then flow that through all the spending and finally come up with what does that mean on a per unit basis. So I'm able to, any of these can be modeled as variables. So if I'm looking to add a shift, I could model the addition of a shift. So effectively it starts with volume, the volume drives the cost, but then the costs have their own independent variables that can be adjusted as well to model the financial impact of a particular decision.
That was absolutely incredible. Thank you so much for that demonstration. So to close us off, could you give us some examples of some of the results of your Power BI planning solution?
So the ability to perform multiple simultaneous simulations is really powerful, and is really allows us to take what are really complex analysis driven off of certain contemplated decisions and make them quickly show the financial impact. And that's it saves a lot of time, it saves a lot of effort, but what it also allows you to do is perform, it gives you the opportunity or the bandwidth to perform a lot more thorough analysis, to evaluate that many more options. So it's not just a time saver, it also allows us to do more thorough analysis and provide quick feedback as to the impacts of that analysis, and allows us, what we're hoping is it will allow us to make more informed, more thoroughly analyzed decisions with the capability to save the simulation we decide to go with. You can save it to the cloud and compare back to it as time goes on. And I didn't even go into much of the cross drilling and the drilling down and all that kind of stuff, which is available as well. But you're able to quickly explore data just with mouse clicks and just holding down the control key and selecting multiple things and getting multiple intersections in the analysis. That's really powerful and allows a lot of self-service. So folks that used to come and request things from the financial organization are now able to answer the questions themselves in many cases.
Perfect. Thank you so much for being here today and sharing this unique journey that your company has been on with this planning in Power BI and ValQ. And yeah, thanks again. Really appreciate your time.
You're welcome.